today's session on antennas and its types. I am Akshaya, and in this lecture we will explore about what antennas are and their significance and their various types. I think we are all more familiar with the antenna, right? As we know, antennas are everywhere, from your mobile phone, that is your major part in your daily life, to satellites in space. But have you ever wondered how they actually work or why there are so many types? By the end of this lecture, you will have a clear understanding of this question. First, let's define what is antenna. So, antenna is a device used to transmit and receive the electromagnetic waves. It acts as a bridge between the transmitter and receiver, and the air converting the electrical signals into the electromagnetic waves and vice versa. So, antennas are essential in systems like communication system, radios, televisions, radars, and mobile devices. For example, think about your mobile phones. The antenna inside it ensures you can make calls or connect to the internet wirelessly. So, next, why do we need antennas? We need antennas because of they are essential device for enabling the wireless communication. Let's see why they are indispensable. The first need is wireless communication. Antennas make it possible to transmit and receive signal without physical cables. When we are using antenna, we do not need any physical cables or wires. So the next need is long distance signal transmission. So antennas helps to transmit the signal over the long distance by radiating the electromagnetic waves efficiently into the environment. So the third need is frequency specific operation. Without antennas, long range wireless communication would not be feasible, right? So different antennas are designed for specific frequency range, enabling the application in various domains like radio, microwaves, and ultra high frequency bands. So the antennas are needed for frequency specific operations. The next need is enhancing signal strength and coverage. Antennas amplify or direct the signals to improve the communication range. For example, the directional antennas focus the signal in a specific direction, while the omnidirectional antennas transmits the signals in only in a 360-degree coverage. So the next need is eliminating the physical limitations. The antennas enables the communication in scenarios like wired or impractical communications. So the fifth need is eliminating the physical limitations. The antennas enables the communication in scenarios like wired communications are impossible. So it eliminates the physical cables. So the sixth need is enabling mobility and portability. So antennas allow for portable and mobile devices like smartphones, laptops, wearables. These are playing major role in day-to-day life. They also support the technologies like autonomous vehicles, drones, and IoT devices. The next is broadcasting and multicasting. They are the key in delivering information to the large audiences as seen in TV and radio and broadcasting. Also, it is used in networking for multicast communication where the data is sent to multiple devices. So the last we need is important need for space communication. So it is essential for deep space mission and satellite communication. Now let's look at the types of antenna. Some common ones include wire antennas, aperture antennas, array antennas, reflector antennas, microstrip patch antennas, helical antennas, slot antennas, smart antennas, traveling wave antennas, reconfigurable antennas, active antennas. So each type has unique features and applications depending on the communication requirements. The first type is wire antennas. First we will see about what is wire antenna. So these wire antennas are made up of thin wires commonly used for low cast and so the first type we are going to see is about wire antennas. These wire antennas are made of thin wires commonly used for low cost and straightforward communication system. The most common types of the antennas include dipole antenna. Here is the image of the dipole antenna. Next, monopole antenna, loop antenna. We will see these types one by one. The first type of wire antenna is dipole antenna. So this dipole antenna has two straight metallic rods. Here is the image of the dipole antenna, and this dipole antenna has two straight metallic rods, and it is widely used in AM or FM radios. It operates at the half of the wavelength of the frequency used. The next type is monopole antenna. This is the example of the monopole antenna, and the monopole antenna is a single rod over a conducting ground plane. It is based on the omnidirectional pattern, which means the radiation pattern of the antenna that radiates and receives the electromagnetic waves equally in all directions. Imagine the antenna is at the center. The radiation spreads evenly in all directions in a circular manner across the surface like ripples on the water. When we drop a stone in the water, it will cause ripples in the circular shape. So it works like this. This monopole antenna works like that. So the next type is loop antenna. So the loop antenna consists of loop or a coil of wire. The metal tubing or printed circuit board trays. The structure of the loop antenna can be circular, rectangular, or any closed shape. Here is the image of the circular loop antenna, and this is the image of the square loop antenna. So the next type is aperture antenna. These are nothing but aperture or opening in the antenna. So these antennas have an opening through which the energy is radiated. The aperture available on the antenna surface will allow the electromagnetic energy to get produced throughout, otherwise to get the transmitted energy. These antennas operates at a higher frequency. The most common type of aperture antennas are horn antenna, parabolic reflector antenna. The first type is horn antenna. This is the image of the horn antenna. Have you ever seen the large horn-shaped structure used in radars or satellite stations? That is the horn antenna. It has a flat, hollow metallic structure. It directs the electromagnetic waves in a specific direction, make it highly efficient for directional communication. It is typically shaped like a horn, either rectangular or conical. The flare at the end allows it to radiate electromagnetic waves efficiently. Think of it as a megaphone for electromagnetic waves. Notice how hollow the structure widens to focus and amplify this radiation in the horn antenna. So the next type of antenna is a parabolic reflector antenna. Have you ever seen a satellite dish on your rooftops or large dish used in observatories? Those are the parabolic reflector antennas. These parabolic reflector antenna consist of parabolic shaped dish and a feed point. And this curved surface is designed to reflect the electromagnetic waves. So this is the parabolic shaped dish, and this is the feed antenna, right? So it is positioned at the focal point of the parabola. It is used to transmit or receive the signals effectively. So when the feed antenna transmits the signal, they hit the curved reflector and bounce off as parallel rays, creating a narrow and highly directional beam. For example, imagine you are watching the TV at your home. The dish on your rooftop collects the signals transmitted by a satellite in space. The parabolic reflector focuses the signals onto the feed antenna, which then converts them into a data for your TV. So these parabolic reflector antennas are mostly used in satellite dishes, radio telescopes. So the next type of antenna is array antennas. If one antenna is not enough to get the job done, what could we do? We could combine multiple antennas to work together. That's exactly what an array antenna does. As you can see in this picture, Many multiple array elements are combined together to work together to get the job done, right? So an array antenna is a system of multiple antennas working together to create a specific radiation pattern. By doing so, they improve the performance, directionality and coverage. Think of it like a team of flashlights. If each flashlight points in the same direction, the combined light is much brighter and focused, right? So that's how array antennas work. The most common types of the array antennas are phased array antenna, Yagi-Uda array antenna and log periodic array antenna. First we will see about what is phased array antenna. This phased array antenna looks like a grid of antennas with electronically controlled phase shifts. It can steer the beam electronically without any physical movement. So it is used in applications like radar, military communication and 5G networks. So the next type of array antenna is Yagi-Uda array antenna. You have likely seen these on TV antennas on your rooftops. So these are the traditional classical element Yagi-Uda array antennas used in 90s and 80s. So the structure of the Yagi-Uda array antenna looks like multiple parallel elements. It is high directionality and compact design. It is used in applications like television reception and amateur radio. So the next type is a log periodic array antenna. So log periodic array antenna is ideal for wideband TV antennas and spectrum monitoring. It looks like a series of dipoles of varying lengths and arranged in a specific pattern. Here is the image of the log periodic array antenna. It also is similar to the Yagi-Uda array antenna, but it also looks like a Yagi-Uda array antenna, but it differs it is in the zigzag pattern. So the next type of antenna is reflector antenna. An antenna that is designed for reflecting the incident electromagnetic signals originating from the separate source. So it is designed to function at a higher microwave frequencies. It is most popular with the spacecraft antenna system due to its lightweight and simple structure. It is made with various reflectors whose surface is hyperbolic, parabolic, spheroid or ellipsoid. So the parabolic is the most commonly used reflector antenna. The first type of reflector antennas are plane reflector antenna. This plane reflector antenna is a simple flat metallic sheet placed behind a radiating element. It reflects the waves to increase the antenna's gain and reduce the backward radiation. It is used in low frequency and experimental setups. Here is the image of the plane reflector antenna. Here is the flat sheet and it is called as a reflector, and this is the feed point. So the second type of reflector antenna is corner reflector antenna. This corner reflector antenna is made up of two flat reflecting surfaces positioned at 90 degree angle. Here you can see this picture. It is two flat reflecting surface and it is in the 90 degree angle. So it redirects the waves into a focused beam and reduces the interference. The advantages of the reflector antennas include compact and provides moderate gain. So the applications like ultra high frequency television antennas and some radar systems. So the next type of reflector antenna is parabolic reflector antenna. It is curved parabolic shaped reflector with a feed antenna at its focal point. So it works like waves from the feed are reflected as parallel rays, creating a highly directional beam. So the advantages of the parabolic reflector antennas include high gain, narrow beam width and minimal signal loss. So it is used in applications like satellite dishes, radio telescopes and microwave links. And this is the picture of the parabolic reflector antenna, and here you can see the parabolic structure. This is a paraboloid and the reflector, and this is the driven element. So the next type of reflector antenna is spherical reflector antenna. This spherical reflector antennas uses a spherical reflective surface instead of a parabolic one. You can see this picture of the spherical reflector antenna, and here you can see the spherical structure. It can receive the signals from a multiple direction, and this type of antennas are used in applications like radio telescopes and multi-beam systems. Now let's see about microstrip patch antennas. Have you ever used a GPS device or mobile phones connected to Wi-Fi? If yes, then you have experienced the benefits of the microstrip patch antenna. The structure of the microstrip patch antenna is like flat, rectangular or circular patches made of two metal mounted on a dielectric substrate with a ground plane. You can see the picture of the microstrip patch antenna. Here is the ground plane, this is the ground plane, and this is the substrate, and this is the metallic patch, that is the conducting material. It is the features of the microstrip patch antennas include a lightweight, compact and suitable for high frequency applications, and it is mostly used in mobile devices, GPS receivers and IoT systems. So the microstrip patch antenna is a key innovation in modern communication technology. Its compact design, cost effectiveness and its versatility make it indispensable in our daily lives. So the metallic strip antennas consist of two main parts. First one is metallic patch, next is dielectric substrate, then the third one is ground plane. So this metallic patch, which is the radiating element, typically rectangular or circular, it can be of any shape, and it is the conducting material here. Then the second one is dielectric substrate. This dielectric substrate is a material that supports the patch and separates it from the ground plane, and this ground plane helps to direct the radiation. So next we explore about the helical antennas. This helical antenna is a versatile component used in various communication systems. The helical antennas consist of conducting wire wounded in a shape of helix mounted over a ground plane. It supports different modes of operation such as normal mode and axial mode. Here you can see the picture of the helical antenna, and it is a ground plane, and here you can see the helical structure or the wounded structure here. So these helical antennas are circularly polarized radiation used for long distance communication, and applications like spacecraft communication, satellite links uses the helical antennas. It produces circularly polarized waves coupled with its wide bandwidth and directional capabilities make it valuable for modern communication system, especially in satellites and space communication. So the next type of antenna is slot antenna. A slot antenna consists of a rectangular slot cut out from the metallic surface such as a conducting sheet or waveguide. Here is the image of the slot antenna, and this is the conducting sheet or metallic waveguide. Waveguide means it is used to guide the or transmit the waves, and here you can see the cut from this surface. So when this slot is energized, it radiates the electromagnetic waves functioning similarly to a dipole antenna. So it much more similar to the dipole antenna. So it looks like a flat metal sheet with a precise cut or slot in it, and this slot allows the metal sheet to emit the radio waves effectively. So these slot antennas are easy to integrate in the surface. Its simplicity of their design makes them inexpensive to manufacture. And these antennas are mostly commonly used in broadcasting like TV, radio and radar systems and aerospace. So the slot antenna typically consists of two surface, two parts. One is metallic surface, the another one is narrow slot. And this metallic surface is a conducting sheet and the narrow slot cut into the surface, usually rectangular in shape. So the next type of antenna we are going to see is about smart antenna. This smart antenna enhances communication performance by dynamically adapting its radiation pattern and beam direction using signal processing techniques. It is used in modern wireless communication systems like 4G, 5G and Wi-Fi. And these smart antennas adjust their radiation patterns to optimize the signal transmission and reception. These antennas are also known as adaptive array antennas or multiple antennas. So the key features of the smart antennas are beamforming, adaptive operation, adaptive user support. So they achieve the above said features by processing the spatial information to identify the direction of the incoming signal and focusing the antenna's beam accordingly. So the main advantages of the smart antenna is by focusing energy where it is needed. The smart antennas allow for more users within the same frequency spectrum, effectively increasing the network capacity. So the applications of the smart antennas include telecommunication, radar system. So the applications of the smart antennas include telecommunication, radar system and IoT networks. Technologies like long-term evolution, 5G networks, IoT networks uses the smart antennas to manage the complex signal environment of the urban areas. It also enhances the target detection and tracking capabilities by focusing on specific direction and reducing the noise. So the next type we are going to see is about a traveling wave antenna. These traveling wave antennas radiates electromagnetic waves as the current travels along its structure in the form of traveling wave. Unlike standing wave antennas, energy in the traveling wave antennas radiates progressively along their length, making them efficient for wideband applications. So unlike traditional resonant antennas, where the standing waves are established due to the reflections, but traveling wave antennas are designed to support the waves that travel in a single direction without reflecting back. We can achieve this by terminating the antenna with a resistor that matches its characteristic impedance, ensuring minimal reflection. So the features of the traveling wave antennas include wideband operation, low reflections, simple design and directional radiations. So the most common applications of the traveling wave antennas are high or very high frequency communication, satellite communication, radio astronomy. The most common type of traveling wave antennas are beverage antenna, rhombic antenna, helical antenna. It is the simple to construct. It offers constant impedance and its non-resonant design allows for efficient operation over a wide frequency range. So the next type of antenna is reconfigurable antenna. Imagine an antenna that can change its properties like frequency, radiation pattern or polarization in real time. That is, in a real time it changes its characteristic features efficiently. So that is the reconfigurable antenna. These antennas can adapt to different requirements, enhancing the performance and flexibility in various communication systems. So the reconfigurable antennas dynamically modify its characteristics such as frequency, polarization, radiation pattern or a combination of these in response to changing the operating conditions or requirements. So this adaptability makes them highly versatile and efficient in modern communication system. So the key features of the antenna, reconfigurable antenna are frequency reconfigurability, pattern reconfigurability, polarization reconfigurability. The reconfigurable antenna achieve their adaptability through various methods like electronic switching, which integrates components like pin diodes or RF MEMS or varactor diodes, and this switches allows the antenna to alter its structure. The next is using smart materials whose properties can be altered by external properties like voltage or temperature to achieve reconfigurability. So the applications of the reconfigurable antennas include wireless communication, military, satellite communication, and also it includes cognitive radios, IoT networks. So the next type of antenna is active antenna. This active antenna integrates active electronic components like amplifiers, mixers, diodes, pin diodes, varactor diodes, etc. So it integrates the active electronic components such as amplifiers or signal processing circuits directly within the antenna structure. These components enhance the antenna's performance by amplifying the weak signal or enabling the additional functionalities such as filtering or frequency conversion. So the key features of the active antennas include integrated amplification, compact design, and wide frequency range. And the applications of the active antennas include satellite communication, military communication, and everywhere. So if you have any questions or need clarifications, drop them in the comments. Thank you for joining this lecture. I hope you find it insightful.